Well, good morning, pre-calc. Here's what you do now. Make some substitutions, see if you can rewrite each of these two problems using only sine. Hey, good work. Let's see what we come up with. Well, the first one, we can substitute using the Pythagorean identity, that is 1 minus sine squared of theta. The second one is not possible. There are substitutions we can make for cosine, such as 1 over secant, but there is no way to rewrite that using only sine. So, important difference between number 1 and number 2 is that squared. Cosine squared, we can make a substitution to write in terms of sine. Cosine is just cosine. So we'll be looking at solving today, solving trig equations using factoring. And we have today some opportunity perhaps to use our identities again. We've not used those in a little bit, so quick refresher. We've got identities. Our strategies for simplifying trig expressions. We're at factoring. It's the last on our list. And we have some steps for factoring. And make sure that equation is set equal to 0. That is the most important. It's the foundational step. And then we factor pretty much the way we've always factored. Ending with taking our trig ratios to the unit circle to get our final answer as an angle in radians. So first example, find all the solutions to the trigonometric equation in this interval from 0 to 2 pi. Our equation, 2 cosine squared of theta plus 3 sine of theta minus 3 equals 0. I've highlighted the two different trig functions. We can see those are different trig functions. You've got cosine squared in green, you've got sine of theta in blue. And as long as we have two different trig functions present, it's going to make factoring very challenging. There are some problems you can factor that have different trig ratios, and we'll see one in a minute. But this one, as a trinomial, we cannot factor a trinomial with different trig ratios. So we're going to need to make a substitution for one of those two trig ratios to try to write it in terms of the other. So the blue one, sine of theta, there is no possible substitution we can make for sine of theta to write it in terms of cosine, just like we saw in the do now with cosine. You can't go either way. But with the green term cosine squared, we can make a substitution using the Pythagorean identity. And so that will be our first step. I'm going to substitute 1 minus sine squared of theta into place of cosine squared. Then I will need to distribute and simplify. So I distributed the 2 into the parentheses to result in my next step. And then I need to simplify. There were a couple of different things I wanted to simplify. I have like terms I need to combine. Those are highlighted in yellow. And I did not want to have that sine squared term with a negative coefficient. And so I went ahead and multiplied by -1 kind of all at the same time. So the -1 is going to multiply onto the sine squared of theta term to give me positive 2 sine of theta. The -1 is going to multiply onto the sine of theta term to give me -3 sine of theta. I did first combine the positive 2 and the -3, those yellow constants, to get -1 before multiplying by -1. So I end up with +1. Right now I can factor. So I am going to make a u substitution first of all, get rid of that sine of theta just temporarily and change it to a u. So I got 2u squared minus 3u plus 1 equals 0. And now I can factor. So I've highlighted all my constants. I got to multiply the yellow and blue together, that leading coefficient together with the constant to get 2. And then I make my list of factor pairs that would multiply to get 2. Select out of that list the pair that is going to add together to give me the green center constant. All right, so now I can rewrite that equation, breaking apart that center green term into 2 pieces, and that will fit into my factor box. And then I look for common factors and broke this apart. So across the top row, common factor of u. To get the 2 terms on the top, that top u multiplied by 2u gives me the first square term in the first square. that red u multiplied by the -1 is going to give me -1u, and then I move to the second row, the 2u multiplied by what would give me this bottom term. So it's going to be a -1, and then double check the two terms which are currently circled. Do they in fact multiply together to give me this bottom right square? They do. So my two factors, in blue, 2u minus 1, and in red, u minus 1. Don't forget those still multiply together to equal 0. Move on to the next step. Now that I have it factored, I can break apart that equation into its two parts. Set each of those two parts equal to 0. That is the zero product property in action right there. Solve each of those equations. And lastly, I need to substitute that u back into the original form using the trig function. So I rewrote both of those as sine of theta. Sine of theta equals +1/2 for the blue one, sine of theta equals 1 for the red one. And now my final step is to go to the unit circle to find which radians give me those coordinates. So of course, sine of theta refers to the y coordinate on the unit circle. And so let's go to the unit circle before we uncover those solutions down there. Y coordinates of +1/2, y coordinate of +1 on the unit circle. So for +1/2, there are two different angles that will give me that +1/2 as a y coordinate. That's pi/6, 5 pi/6. And +1 as the y coordinate is only one place to get that at the very tippy top of the unit circle. It's pi/2. So my final solutions, theta equals pi/6, 5 pi/6, and pi/2, organized by which factor they came from and colorized. Check out another example. So again, we have an equation, a trig equation to solve. And the first thing I noticed in here is I again have two different trig functions. I've got cosine of theta and tangent of theta both appearing in this equation, which in the last equation was problematic. We needed to make a substitution. However, this equation is a different type of equation. It's not a trinomial, so I'm not trying to factor it as a trinomial, which I would not be able to do with different trig functions. It's just a binomial. I've got two terms. I got a green term, I got a blue term. And each of those two terms does have a common element. And so I'm going to factor this by factoring out the common factor of cosine of theta, which I've underlined in the purple squiggles. So cosine of theta comes out. Inside the parentheses, I would need tangent of theta -1. So there's my two factors. I got the pink and the purple. That still is set equal to 0. I can now proceed with my factoring process. Those two factors I can separate and set each of those factors equal to 0. The purple one, I don't have to solve any further. Cosine of theta equals 0. The pink one, I'm going to take another step here to solve that for tangent. And then let's go to the unit circle. Cosine of theta, that is the x coordinate on the unit circle. So I'm going to be looking for an x coordinate of 0. And tangent is the y coordinate divided by the x coordinate as a fraction or division problem, either way. And the only way I'm going to be able to get y divided by x equal to 1 on the unit circle, just think about this for a moment, is the y coordinate and the x coordinate will need to be identical. Right? That's the only way I can divide one thing by another thing and get an answer of 0. Need to be identical. So I'll be looking for points on the unit circle where both the x coordinate and the y coordinate are exactly the same as each other. That is what I'm looking for tangent of theta to be equal to 1. So x coordinates equal to 0 for the purple part that's highlighted in green, and identical x and y coordinates for the pink part highlighted in blue. Now let's go to the unit circle and find these. So for an x coordinate of 0, I'd be up here at pi/2, the tippy top of the unit circle, or directly below it, 3 pi/2 down here at the bottom. Each of those has an x coordinate of 0. And for my tangent equal to 1, I need the x and the y coordinate to be exactly the same, which happens first at pi/4, both radical 2/2 and radical 2/2. Also, diagonally across down here in quadrant 3, negative radical 2 over 2, and negative radical 2 over 2. So there are some other places on the unit circle that seem like maybe they would work, but the coordinates are not exactly identical. For example, 3 pi over 4. Very similar x and y coordinates. However, one is negative and one is positive, and so that is not going to give me a tangent value of positive 1. So my 4 solutions, pi over 4, pi over 2, 5 pi over 4, and 3 pi over 2. And so I've written those down here, organized by which factor they came from and colorized accordingly.